Hi, this is Dan Breeker at the University of Texas. And in this video, I'm going to go over how to fill out the age data tab in the paleosol template for the CO2PIP project. If you haven't seen the other videos, there's one about a general overview of all the tabs, and then there's one covering more detailed information about the paleosol data tab. You might check those out as well. The first thing I want to show you is that on the upper left of this tab, there's a cell that says on this sheet, each row corresponds to a unique stratigraphic depth or a stratigraphic level at which the age has been estimated. And that is different from the rows on the paleosol data tab. And that's important. That difference is important for the way to fill out this sheet. I'm going to go through, I'm going to look at columns A and B here, both of which also appear on the paleosol data tab. Column A has the section number. This doesn't apply to every study, but some studies use a number of different sections, compile them together to get one kind of composite record. And we want to be able to disambiguate one section from another. And so I've included a column with which you can do that. Column B is the stratigraphic level. There's also a stratigraphic level column on the paleosol data tab. And here, what we want is the stratigraphic level at which the age by some means is known. And what that means, I guess what the best way to explain that is that the stratigraphic levels at which you're going to be entering data on the age data tab are probably in most cases not going to be the same stratigraphic levels for which the data relevant to CO2 reconstructions are being entered on the paleosol data tab, right? I mean, if you think about the way that these studies usually work, usually the way this goes is that you know the age maybe at the top or maybe somewhere in the middle, right? A few places throughout the section, and then the materials that are relevant to atmospheric CO2 reconstruction, right? They occur throughout the section at various stratigraphic levels, and we get a number of CO2 estimates, but we have ages only from maybe a few stratigraphic levels, right? And so on this tab, we are focusing on the levels at which we know the age by some means. Okay, I'm going to move over to column C here, which is the type of age constraint. And there's a number of different, we've tried to design this for maximum flexibility. There's a number of different ways that you can use this. And this is a pull down menu, right? So you could say that my age at this stratigraphic level is less than some value, or less than or equal to some value, or equal to some value, so on and so forth, right? So maybe best to just give some examples about how this might work. Let's say that you are entering data for a study where the age depth model was based on magnetostratigraphy. You might put in an equals here, and you might put in the age, right? So there's going to be some stratigraphic level at which you know that there's a reversal occurred, right? You're going to put in an equal sign. You're going to put in the age for that particular reversal, and then you're going to put in the uncertainty on the age of that reversal. And then over here, where it says magnetostratigraphy, right, you're going to put in the information relevant to, okay, which cron boundary you're talking about. Right, so that's an example of where you would use the equal sign. One thing that has come up is that, especially as we go back further in time and look at some records from the Mesozoic and Paleozoic, that there may be examples, and actually there may be a lot of studies in which all you really know is the stage. So an example has come up like lots of times, like all we know is that the age is aptian, and how can we enter information into this that helps reconstruct or helps generate an age depth model, or helps influence the determination of the age of the samples that we use to reconstruct CO2. So if all we know is that the age is aptian, here we can come over and say, we might not even know the stratigraphic level. Maybe you know the stratigraphic level. In that case, you can put a number here. Maybe you don't know the stratigraphic level. Maybe you just want to put in top of section, right? And you know that the top of the section is still in the aptian. The bottom of the section is the aptian, the middle of the section is aptian. Everything's aptian, and that's basically all you know, right? In that case, you can put that the top of the section, right, has got to be greater than or equal to the age what's the Aptian, 1710, something there, the age of the top of the Aptian, and then you can put in the uncertainty, right? How well do we know the age of the top of the Aptian? Not as in this particular study, but in general, what is the uncertainty on the age of the top of the Aptian? Right? And this greater than or equals to sign here helps us know that, well, we know it's Aptian, but if it's still, if the top of the section is still Aptian, we know that has to be older than the age of the top of the Aptian. So that's what greater than or equal to. So if you knew that you definitely did not have the top of the Aptian, right, you could modify this and you could say, well, actually, it's not greater than or equal to. I know that the top of the section is actually older than the top of the Aptian. So you could use the greater than sign. Then we could have a second row here for the bottom of the section, right? We know that that is either less than or equal to, or maybe you know that you don't have the bottom of the Aptian and you say less than the age of the bottom of the Aptian, and then again, the uncertainty on the age or the bottom of the Aptian. And then you could put in, how do we know, how do we know that the samples are Aptian or the section is Aptian? You could put in the biostratigraphic information that's relevant to determining the age. And so these greater than or equal to signs allow you to hopefully cover any scenario with all these different methods for determining age that are at least all of the common methods, right? So we have biostratigraphic methods or stratigraphic methods, including magnetostratigraphy, biostratigraphy, chemostratigraphy, so on and so forth. We also have radiometric ages, right? So there might be certain stratigraphic levels where, type of deposit, maybe it's a volcanic ash. Actually, this is a pull down menu. So I can say, okay, I dated a volcanic ash from the section. Okay, I don't know why it's not accepting volcanic ash. Oh, there we go. Okay, so it's a volcanic ash, dated a volcanic ash, and what mineral from the volcanic ash. Okay, maybe you did sanidine, and in this case, right, if you're dating sanidine in a volcanic ash, you could come back over here and you could say, well, I know that at this stratigraphic level, and let's say, whatever, it's 59 meters in your section, let's delete that one, right? If you're dating that ash, you know that it's equal to that age. And so that's how you can use these. I'll just leave that there for now. Right, so it's equal to whatever age that is. Then there's other options here. I just wanted to go over that, just trying to ask for as much information as possible to evaluate these data when we look back on them in the future. All right, so there's things that are asked for, like the decay constant used, what's the radiogenic system that was used to determine the radiometric age. There's also columns that are relevant to detrital zircon geochronology, right? So these columns over here, detrital zircon, right? The type of depositional age, so on and so forth. Right? So these are also pull down menus, right? There's many different ways that people use detrital zircon data to determine the age of sediments. Right? And so when you have a detrital zircon age, right, you know that the sediments are younger than the zircon age. So you could come over here, and if it was detrital zircon, you could say that, well, I know that I have a detrital zircon age, and I know that my samples are younger than, less than, or equal to that detrital zircon age. Right, so I'm just trying to give you some examples of how you might use column C here to help fill out this spreadsheet. Finally, there's a notes column, because we recognize that this, although it's fairly flexible and we've gone to effort to try to include as many different types of common methods here as possible, we recognize that there's probably going to be things that we haven't included columns for. And so if the age constraints are based on something that you can't enter into any of these columns, you can even provide a detailed description here that will help people if they're going over this sheet. And the last thing I wanted to say here is that really, right, with the stratigraphic level and the age, what we're really trying to do here is to provide all of the data that are necessary for determining or creating an age depth model that has a rigorous uncertainty quantification associated with it. And so even if that wasn't done in the original, let's say we're filling out an archive file, but even if that wasn't done in the original paper, right, we want to provide any data that were reported in that paper, right, should go here so that in the future people could come back and say, okay, right, I'm going to revise the ages from this paper based on a new method that we have to determine age depth models and their uncertainty from known ages at various stratigraphic levels. Right. The point here is to archive these data and then be able to carry them forward as new methods become available, and as even as we're going to eventually update these with product files, right? And the product files will be able to change ages if new constraints, add ages if new constraints are available, if change things, if things have been updated. So that's when we're going to actually change the numbers. But in the archive file, right, you can still fill out the sheet for an archive file based on ages reported in that paper at various stratigraphic levels. Again, recognize that there's some complexities in these sheets. And so if you still have questions after watching these videos, please reach out to me or to one of the CO2PIP postdocs, and we'd be happy to answer your questions. Thank you for filling out the sheets.